electricity, okay, ever since we started knowing about electricity, we've been dealing with a source whereby we have a source that is supplying electricity using one line. So we had, for example, something like that. We had a source right here, and that source would supply electricity using one line to maybe a certain appliance. And then it will be connected back to the negative. So this one, what we had here, we call this a single phase system. Single phase because we only have one line that is bringing electricity. Now, when you say multi-phase system, now we are going to have a lot of different lines of wires that are going to bring our power. That's where we come to multi-phase systems. So it's not a really difficult thing, but you just need to pay attention, then everything will be fine. So I'm recording this video. So those that might have problems coming in, going out, and the ones that fail to connect, we will still share the video with them. Okay, so let's start. Three-phase system. So I want you to remember in ELC, for those that still remember ELC, there is a time when we came to a point where we were talking about the generation of electricity, and we were using the Faraday's law of electromagnetic induction, where we had poles of a magnet. We had poles of a magnet here, and then we said that we will have a coil. But if we are viewing it from this side, now this is a cross section, you would only view that coil. Maybe you just view like a dot here. So this is just a wire. And then maybe the other end of the coil, you would see it right here. It's just a wire. But if you are going to see this from maybe the top view, you would see that you have a coil like this that is in between magnets. So this is the end that we were seeing. These are the two ends that we were seeing. So this one is what is actually in this section here. So our magnet is actually like this. Oh, let me just try to draw it. Okay, it's fine. So our magnet is somewhere here.
Roma.
Yeah. Yeah, the ones that are joining, because we have already started the class, can you just maybe mute your mic, and you unmute it when you want to ask, when you don't understand a certain thing, or maybe you want to give a suggestion, you can just unmute and speak. Okay. So what we have here, these are two magnets, and we have the North Pole here, the South Pole here. So what we are seeing is a coil. So if you look at this diagram, we are just looking at this arrangement from this side. So remember drawing, I don't know what that is, the front view or the side view. So if you go into this diagram, we are just going to look at the two ends, these two ends. So we explained that when this coil rotates in this magnetic field, there's going to be electromagnetic induction. Electricity is going to be induced in this coil, okay? And an EMF is induced or is created. So we are going to have a creation of an EMF. Now this was single phase. Now in multi-phase systems, what we are going to do is we are not going to put one coil. We are going to put three different coils that are not connected. So you will see that instead of me having an arrangement like that, what I'm going to do is, let me erase this. I'm going to take the first one, I'm going to put it in red, and I'm going to put it right here. Right here. So this is the end of a coil. This is another end of the same coil. This one end is the other end. So this one, I will call this the red coil. Okay. Then let me do some drawings here. Some drawings maybe in a blue color. Red, white. We had red, yellow, blue. So I'll do the drawing in a faint green color. Okay. So I want a perpendicular line. Yeah, no, this is not the color. This is not the color. Faint green. I just want to use this for reference so that when I'm explaining it becomes easier. Okay. And I have another one there. Okay. So now this red part is showing one coil that we represent as red. So we use this color notation. So the first one is the red conductor. So let me say that the top part is the entrance. Let me just say the top part is the start and the end. Okay, it's fine. Let me call this R. And this one I'll call it red. Let me call this R. Let me call this. So this one is R1, is R2. Now, what happens is when we connect these, we connect the second line in yellow, using yellow. And that one will be 120 degrees behind the red one. So if I say that this R1 here is the one that is in front, is the one that is in front, then 120 degrees behind this R1, we have the yellow line. So if this is a 90, then 120 will be somewhere here. So I'm going to say, right here, I have a yellow line. I'll call this Y1. Then on this other side, I'm going to have another yellow line, which I'll call Y. So R1 is the start, R is the end. Y1 is the start, Y is the end. And then I also have, we will now have to connect again the third line, which is supposed to be in blue. So that one should be 120 degrees behind Y1. So it should be somewhere here. This is one. Please, Max, can you mute your microphone, please?
Okay, Nashap.
Okay. Okay, so this is the scenario. So now I want you to understand this. When we are measuring angles, the positive direction is this one. We always take the anti-clockwise to be the positive direction when we're measuring angles. So that means now if I join these lines, I'm going to try and join them. The red conductors, this one, the blue conductor, that one, and then the yellow conductor is that one, the yellow conductors. So now I'm going to do this now. I want you to see, because in all these coils, we're going to have an EMF being induced in each and every coil. So in the coil, in the red coil, we are going to have an EMF induced, and that EMF is, we call it ER. We're going to call it ER. And because, you know, these are instantaneous values, remember instantaneous values, remember instantaneous values is we have to put the maximum here, we express it in trigonometric form, and then we have sine. And so the first one, I'm going to, yes?
How many degrees behind the yellow is the blue?
Okay, it's 120. We are measuring from here.
Mm-hmm.
So it's 120. So the yellow one is 120 behind the red one. Eh?
Okay.
And then the blue one is also 120 behind the yellow one. So if you want to actually see the degrees, the blue one is actually what, 240 behind the red one, right? You can see that. Eh?
Yes.
Yeah.
Yes.
Okay. So I'm saying now, if we take the red one as our reference, that means it's at a phase angle of 0. I'm sure everyone remembers that one. So I'm going to say now, normally when we are going to put a phase angle, we would say theta, and our phase angle will be somewhere here. Phi will be our phase angle. So now, since I'm going to say now, right here, I'm going to say that our phase angle for the red one is 0. So this one is going to disappear. Okay. So let me make this one a general equation. So I'm going to make this one here a general equation. So we erase the R, then we use this one to come up with the rest of the equations. Welcome, Mr. Joseph. Okay. Why am I writing R? Okay, so this one is an instantaneous value of the EMF in each of those coils. So now if we want to find the EMF in the red coil, we are saying that the phase angle, we are taking this as our reference. So that the phase angle there is going to be 0. So if we are going to write this one, we're going to write ER is equal to EM sine theta. So this one is just sine theta because phi is 0. Okay? We together? Okay. Then
Yes.
we want to find also the EMF in the line, in the yellow line. So we call that EY. So the maximum is going to be EM because these wires are between the same magnet. So they are going to have the same maximum EMF. Okay? Now I'll write sine theta. Now I want someone to tell me what phase angle I'm going to put right here. Who's that? Joseph, your mic is already unmuted. So can you tell me the angle I'm going to put there?
I'm just joining. I don't know where we are.
Okay, yeah. So let me just unmute you for now. Who wants to tell me where the angle I'm going to put there? Junior.
Is it the, didn't you say 120? Something like that.
Yeah, so is it positive or is it negative?
For the yellow, it's, I'm not sure.
Just check the reference is R. And when you are measuring an angle, you go in what? In an anti-clockwise direction. So if Y is here, if Y is behind, eh?
So it's, I don't know.
Isn't it the negative 120?
Negative
120, yeah? Because it's behind most.
Yes.
So we
is
have,
going clockwise.
yes, so we have a negative 120 here. So that is our phase angle for EY. So can I give the, yeah, Eunice, can you write here the EB? Can you write EB? Because I already saw that you had the mark, eh? So right.
Okay. I can write Ngoma.
You can't. Okay, let me give the I'm giving you the oh, it's now telling me other things. wants me to give you permission from somewhere. Let me open that permission. Okay. Okay. Try to write, let's see. Are you failing to write? Eunice, we are waiting. Okay, it seems there is a problem here. Let me just write it myself. Okay, so this one is going to be E M sine theta minus 240. Was we are taking the reference as R. So the EMF in the conductor B is behind by 240 degrees. Okay, so now you see that now these three now are the EMFs that are being induced in our coils. But you will see that they are at different phases, but at some point the maximum magnitudes are the same, but they are just in different phases. So this is a or we can just say a three-phase generator. So it generates an electricity that will come in a three-phase form when it's now being supplied to certain loads. So this is just an introduction. So now let's go to the way we connect these things. So when you are connecting these, we will connect them either in delta or in what is that? Star. They are either delta connected or star connected. So let's look at how they came. Okay, I will skip the whole construction thing. I'll go straight into the delta connection, then we explain from there. Okay. So, hello? Yeah. Sorry? No. Or maybe this person is speaking in their house. Who is this person who is not unmuted? Okay. Let me go to delta connections. Okay, so let's do this. So let's say if I take one coil, I'll represent this coil like that. This is one coil. Let's go.
Mama,
Yes.
like I'm trying to request permission to record the thing.
No, I won't allow you.
Ah,
If you record, then you share with other people.
no, but it's for our own good, like.
No, I'm recording it, so you will have it.
Oh, okay.
Yeah. Don't worry. So the first coil is here, the second coil is here, and then we have the blue coil. I wanted to skip this, but I think I don't have to, because it's important that you understand this. We have the blue one here. So these are the coils that we had in the generator that we just talked about now. And this is the start and this is the end. So on these coils, what we want to do is since they are producing electricity, we want to use them to supply power or energy to certain loads. So if you check in your books in use, you'll find this is there. So what I would do is I can connect okay. We are running out of time. Let me just increase the time because we are running out of time. They are not allowing me. They want me to pay money. So let's just continue. If it cuts, we'll just come back and continue with the video because we are lying here. It's just 9 minutes. Okay. So if I put a load on this one, so let me call this load 1. So this load is being supplied, the energy is being supplied to it by this coil. I can also go and connect another load on the yellow conductor. Then this yellow conductor is being supplied power by, sorry, this load is being supplied power by this yellow conductor. Then I have a third load. That is being supplied by a blue conductor. So now it's like what we have done is we have connected the load across the terminals of each and every wire, okay? Now, this arrangement is expensive because there are a lot of wires included. So what they do is now, because they know that this is the beginning, and if this is the start, that means we have positive EMFs here. This one is our ER, it's positive that direction. This one is our EY. This one is our EB. Okay, so it's positive in this sense. That means that on this point here is negative and this point here is positive. So what they can do is they realize that they can join these 2 points and there won't be any effect if they join these 2 points. So they realize if they join these 2 points, there won't be any effect. Also, if they join these 2 points, there won't be any effect. Now this point will now be joined to the one that is here at the end there. So now, when they do that, you will see in your book is they start by writing, they draw something like that, where they are now connected. And then the loads will now be connected between, you can connect it between this point, and that point. Okay, but eventually what will happen is that when you connect this point and this point, we have now, you will see that it's like there is a complete circuit in this wiring. If you follow this wire, it's like there's a complete circuit here. I hope everyone is seeing this. If you follow this wire, it's like there's because if you join this point and that point, it's like there's now a loop here, which is a complete circuit. Now, if there is an EMF, that means there will be a current that will circulate in this loop. Now that becomes a problem because it would work, our idea would not work in this case. So what we will do, we want to see if it is true that we have a current circulating in this region. So if you take your KVL, you will see that what you're,
Ingoma.
yes. Someone is saying something.
The line is cutting.
Sorry?
The
The network is a problem. Okay, so if you take a,
line was cutting.
oh, but is it now fine? Is someone who's trying to call me? I think that's the person.
Ngoma, I can hear you then.
There's someone who's trying to call me. I think that's
I
the
can
person.
hear. Oh.
But can you hear me now?
Yeah.
Yeah, there's someone was
I
trying.
can hear you now.
Okay. Oh. Oh, my page has just disappeared now. Just wait a bit. Someone is trying to call now. They are disturbing my pages here.
I can't hear shit, bruh. Like this shit is tripping.
Yeah, this is why I was saying this is a trial version. Then we see if it will work. If it doesn't work, I will stick to just recording the videos on my own, and I'll send you guys the recorded video.
Now we can hear Ngoka, so now we can hear. Now we can hear you.
Okay, it's fine.
Yeah. But you said it's until 9:30 most. It's only like 6 minutes left.
Now what I will do is when we cut, I'm going to create, okay, I'll just create a video because I see it's a problem to do this. I'll just create a video, then I will send you guys the link. So let's just finish this. I'll just finish this now. If you take a KVO here, you will see that you will have EB plus EY plus ER. So now that will, let me call that the total EMF that should be between these 2 points. So I said, if there is an EMF here, a current will flow. And if a current flows, that means we cannot connect these things in this way. But let's see if there's going to be an EMF. So we have ET, which is equal to ER plus, EY plus EB. Now, if you do that, we wrote these expressions, and we saw that we had EM sine theta plus EM sine theta minus 120. Then plus EM sine theta minus 240. Now, if we simplify this one, you will realize that we should get a 0. So if I factor out, then I'm going to have a sine. Now here you must remember your tricks. Yeah, you should remember your tricks, your trigonometric ratios. So here I'm going to have a sine theta cos 120 minus sine 120 cos I'm trying to write cos theta plus sine theta cos 240 minus sine 240 cos theta. Now, if you punch this in the calculator, you get a 0. That means there is no current that will flow here, since we don't have an EMF between these 2 points. Okay, so in a sense, that means we can connect these together like that. So we can connect this, I can take this point and come and connect it here. That means we have now what we call a delta connection. We have a delta connection here. So now when you connect these, we will now call this point R. Let's call this point Y, and we call this point B. So the EMF that is here, okay, we connected what? R to the end of B. So this is B1 here. So I'm going to call this point, this one, ER. I'm going to call this point, sorry, this one is EB.